Good morning, sir. This is Ramsan Guiamad from 3BSCA. So my task for today is to discuss how I get my answers in assignment 1 under the book of Segway, Still Design 5th edition, chapter 2 problems. First question, a column in the upper story of a building is subjected to a compressive load from the following sources. Dead load, 30.8 kips, occupancy live load, 1.7 kips, roof live load, 18.7 kips, and snow load, 19.7 kips. First na ginawa ko dito is na ikuha ko muna yung mga givens nila. Ayan, kasi yung givens na yan yung gagamitin natin ngayon. Next, meron tayong question dito na if load and resistance factor design is used, so matik na yun siya, LRFD ang combination ang gagamitin natin. Determine factor load required strength to be used in the design of the column, which AISC load combination controls. So ngayon, before tayo magsa-substitute, i-apply muna natin yung observations natin. Yung given natin is walang wind or earthquake, so pwede natin itong alisin. Kasi as you notice here, habang dumadami yung combinations natin, bumababa din yung constant natin. So if wala tayo nito, that means 0.9 times D, mataas ang 1.4D. So cancel ito. Next is combination 4. Yung combination 4, pwede natin i-relate sa combination 2. Okay, equal sila. Wala tayong wind. X to. Next is yung live load natin. Meron tayong 1.6 sa 2 and 0.5 sa 4. So lamang na yun yung combination 2. Next is, kasi ang concept nito is kukunin yung pinakamataas na answer. After yung mga combinations, ano yung pinakamataas na answer, yun yung required strength. So, X na to kasi alam natin na mas mataas yung combination 2 kasi wala tayong wind load. Kasi dito equal lang sila. Okay, next. Combination 5. Correlate natin sa combination 3. Equal din sila. Next ito, 0.5. Example, wala tayong wind, no? So, X to live load lang. Wala tayong earthquake din. Live load, okay, equal sila. Ngayon, yung snow, 0.2 lang. Dito, ang snow natin is 1.6. So, kung naman ulit, X naman yung combination 5. So, magagamitin lang natin dito, since wala tayong earthquake and wind, gagamitin lang natin dito is combination 1 hanggang 3 lang. So, yun. Ngayon naman, dito naman, ano naman to, bakit tatlo? Ang purpose dito is gagamitin yung pinakamataas. So, given natin kanina, ang roof live load lang natin is 18 point something lang yun. While ang snow natin is 19.7. So, ang gagamitin natin ngayon ang 19.7 kasi yung rain natin is wala. Substitute lang natin first combination 1. Substitute lang yung dead load. Plus yun na. Ito na yung answer na. I-times lang yun siya. Next, combination 2. Sa substitute natin. Times mo to, times mo to, tapos add sila lahat. I-add mo sila lahat. Ganun lang. Ganun lang din sa iba. Okay? So, this question, try ko lang isa-substitute lahat-lahat or gamitin yung lahat-lahat ng combinations. As you notice, wala talaga. Mas mababa talaga siya. Okay? So, ang sagot ko dito is combination 3 controls. And factored load is 69.33 kips. Yun yung pinakamataas dito sa combinations na to. Okay? Okay, next question. Letter B. What is the required design strength of the column? So, ang required design strength that is consists of resistance factor times nominal strength. So, ang formula natin from the book is required strength that is less than or equal to resistance factor times nominal strength. Therefore, ang required design strength natin is 69.33 kips. So, yun. Ganun lang. Yun na yung answer natin sa B. Next, letter C. What is the required nominal strength of the column for a resistance factor 0.9? So, solution natin. Formula natin ulit galing sa book. Yan din yung sa B kanina. So, meron tayo dito ang formula. Okay, ang gawin natin, derive muna natin formula para maging alone yung nominal strength natin. So, divide ako both side with resistance factor. Okay, cancel to. Cancel. So, ang kuha natin, ang nominal strength natin, that is equal to required strength all over resistance factor. And then, substitute ko yung required strength ko from kanina, yung nakuha kanina sa letter A ba yun? Okay, substitute. And then, yun, divide na sila. RU over resistance factor. And ang nominal strength ko ngayon is 77.03 kips. Yan yung answer ko ngayon sa C. Next is the D. If allowable strength design is used, automatic na yun siya, that is ASD combination. Determine the required load capacity or required strength to be used in the design of the column, which AISC load combination controls. Apply ulit tayo ng observation. Wala tayong wind and earthquake, di ba? So, alisin natin yung combination 7 and 8, tapos combination 5. Ngayon, sa combination 6A, as you can see, pwede natin siyang i-relate sa 4. So, meron tayong D, that is equal. Next, 0.75L, that is equal ulit. Wind, wala. So, 0 to 0.75, equal din siya. So, meaning, if wala tayong wind, ang combination 4 and combination 6 is equal lang. So, pwede natin alisin yung combination 6. Pwede natin alisin yung combination 6A. Next is combination 6B. Relate ulit natin sa combination 4. Okay? Don't mind yung positive and negative kasi hindi po natin yung pinakamataas. So, if wala namang negative, so kahit positive lang yung consider natin. Next, snow natin. Snow. Given ko yung snow, tapos snow rin dito kasi yan yung pinakamataas. As if ma-remember natin yung sa given. So, equal lang ito sila. Next earthquake, wala ang earthquake. So I think equal lang din ang 6B. Okay, so ang gagamitin na natin is combination 1, 2, 4 lang. Okay? Next is substitute natin yung D, kasi dead load niyan. So ang combination 1 na sagot niya is 30.8 kips. Next naman is D plus L. So ang sagot, ang substitute lang natin, simple algebra lang naman to. Kasi first topic pa lang, so alam na siguro yan paano yung substitute and then add. Next, since tatlo to, kunin natin yung pinakamataas. So yun yung ilalagay natin dito. Pinakamataas sa given is yung snow, 19.7. Kaya ito, 19.7. Yung isa kasi 18 point something yun, so hindi yun siya pwede. Ang goal kasi natin dito is makuha yung pinakamataas. Meron tayong sagot dito na 50.50. Combination 4, ganun pa rin, substitute pa rin. If you notice, combination 3 ang pinakamataas, so combination 3 controls. And the required load capacity is 50.50 kips. Yun na, ganun lang yun. Next is E. What is the required nominal strength of a column for a safety factor of 1.67, or that is factor of safety? Formula natin sa book is required strength equal or less than nominal strength over safety factor of safety. So derive muna natin para maging alone yung nominal strength natin dito. Times tayo ng safety factor para makancel to. Ang formula na ngayon natin sa nominal strength is required strength times safety factor. And then substitute natin yung mga nakuha natin, yung RA natin, nakuha natin kanina. Ito, given to yan. Substitute. Multiply yan sila. Required nominal strength natin ngayon is 84.34 kips. Yan yun. Sagot. Okay, number 2. Second question, number 2. A column is subjected to the following load. Dead load, 26 kips. Occupancy live load, 15 kips. Roof live load, 5 kips. Snow load, 8 kips. Rainfall, 5 kips. And wind load, 8 kips. All loads are compression except for the wind load, which can be either tension or compression. So, proceed tayo. Question. If load and resistance factor design is used, RFD yun, determine the factor load or required strength to be used in the design of the column, which AI as load combinations controls. Observations tayo ulit, apply tayo observations. I think in combination 6 and 7, mas mataas to. Tignan nyo. Kasi wind lang to, ito 0.7, 0.9 lang. Dito, may mga live load pa siyang nadagdag. So, cancel natin to. Next, ito wala tayong earthquake, pwede natin itong alisin. So, ang makakonsider natin is 1 to 4 na combinations. Okay? Combination 1, anong ginawa mo sa combination 1, Ram? Yun lang, substitute and then multiply. Ito, multiply. Ito, substitute mo, then multiply, tapos i-add mo silang lahat. Dito, snow ang kunin natin kasi yan yung pinakamataas. Ito yung answer na. Same lang din dito. Okay, so ang kukunin natin yung pinakamataas live load, so 15. Times mo to, times mo to, times mo to, then add mo silang lahat, 51 kips. Next, combination 4. Okay, so dito gilagay ko pa yung combination 6 to prove talaga na mas mababa pa rin talaga siya. Ayan, mababa yan siya. Next is combination 4, 50.7. Concluded natin dito na answer is the combination 2 controls and the factor load is 59.20 kips. By the way, ang kuwan ko dito is 2 decimal places sa lahat-lahat para maging uniform. Next question, what is the required strength of the column? Same lang din sila dun sa kwan. Number 1 question, yun. Same lang din yung sila ng concept. Ganun pa rin. Since required strength is less than or equal to resistance factor times nominal strength, therefore, ang required design strength natin is 59.20 kips strength. Next, see, what is the required nominal strength of the column for resistance factor of 0.9? So, ito, arit, formula. Tapos derive natin para maging alone yung nominal strength natin dito. And then, required strength over resistance factor is equal to the nominal strength. Then, substitute ngayon natin. Yung nakuha natin kanina, 59.20, tapos yung 0.9, divide natin ngayon. 59.20 divide 0.9. Ang required nominal strength natin ngayon is 65.78 kips. Next, if allowable strength design is used, okay, ASD combinations ngayon yan, determine the required load capacity or required strength to be used in the design of the column, which AIS load combination controls. Observations tayo ulit. Kasi mas mataas to compare dito kasi 60% lang dito ang D. So, cancel natin to. With yung 5. Next, earthquake, wala tayong earthquake. Yung CA, pwede yun siya gamitin CA. Okay, CA. Combination 1 to combination CA, I guess. May wind man kasi tayo. Okay, next. Combination 1, 26 kips. Combination 2, 41 kips. Combination 3, 34 kips. Combination 4, 43.25 kips. Combination 5, okay, so gisali ko dito yung combination 7 pero wala pa rin mas mababa pa rin talaga siya. So, ang kunan natin dito, LR. So, ang pinakamataas dito is combination 6A. And the required load capacity is 46.85 kips. Yan yung pinakamataas niya. Yung iba, di na natin gisali kasi understood naman siya na mas mababa kasi wala siyang ibang kon. I mean, unknown yung iba. And then yung ibang kon niya supporting na mag-a-add sa kanya is mas less compared dun sa taas. Letter E, what is the required nominal strength of the column for a safety factor of 1.67? Same din sila no kanina sa E ng number 1. Meron tayo ditong formula tapos derive natin. Meron tayo ditong RA. R sub A times safety factor is equal to nominal strength. And then substitute ngayon natin yan. Substitute. Then multiply to. So, ang nominal strength natin ngayon is 78.24 kips. Okay. Next question. Number 3 or 2-3. The load on the roof beam consists of the dead load of 0.2 kips per feet, a roof live load of 0.13 kips per feet, and a snow load of 0.4 kips. So, tayong wind and earthquake na yun dito. So, sabi ko kanina, pag walang wind and earthquake, alisin natin itong 4 to 7. Diba? So, ang gagamitan is 1 to 3 combinations lang. If load and resistance factor design is used, determine the factor load required strength to be used in the design of the beam, which AISC load combination controls. So, as you notice here, 1 to 3 combinations ang gamit ko kasi yun nga, yung na-discuss ko kanina sa number 1, pwede na ito alisin kung walang wind and load. So, ngayon, same concept pa rin, i-substitute and then simple algebra. So, thus, combination 3 controls and the factor load is 0.46 kips per feet. Yan yung answer sa A. Next question, if allowable strength design is used, ASD combination to, determine the required load capacity to be used in the design of the column, which AISC load combination controls. Solution. So, wala tayong wind and earthquake. Pwede natin itong alisin. So, 5. Okay pa rin yung 5. 1 to 4 lang combination na pwede natin gamitin. Okay, ganun pa rin. Substitute. And then, simple algebra. Pinakamataas natin ngayon is combination 3. So, ang concluded answer natin is combination 3 controls. And the required load capacity is 0.34 kips per feet. Okay. Next question. Number 4 or 2-4. Beams will be designed for the roof and floor system. Meaning, dalawang kon tayo dito. Meron tayong separate sa roof, meron din separate sa floor of an office building. The load for this system are follows. Sa roof, meron tayong dead load of 30 PSF or the pound per square foot. Roof live load 20. Snow load 21 and rain load consisting of 4 inches of water. Floor is dead load 62 pound per square foot and occupancy live load is 80. So sa given natin, medyo may pagkakonto kasi hindi siya fix yung sa rain load natin, pero madali lang yun siya. Dead load, meron tayong dyan 30, roof live load 20, snow 21, rain load. So nabanggit doon, meron tayong 4 inches of water, consisting of 4 inches of water. So ang magagamit natin ngayon dito is yung floor dead load natin na 62. And then yung 4 inches natin i-kukan natin siya into foot. So 4 over 12 na yun siya. Times namin natin sa dead load. So rain load natin is 20.8 PSF. Ang floor natin, dead load is 62 PSF and live load is 80 PSF. So first question, for each of these system, determine the required factor load capacity for LRFD. Which load combination controls? Start muna tayo sa roof load. Sa roof load, wala tayong wind and earthquake kanina, di ba? So cancel na to. 1 to 3 lang gamitin natin. So substitute natin ngayon sila. Combination 2 ang magagamit natin is snow kasi 21 yun siya. Live load sa roof, wala. 0 lang yan siya. Yun. Multiply mo to, then add. Combination 3, same process pa rin. Snow gamitin natin dito. Wala tayong live load, wala tayong wind. 0 to. Okay, 69.60 PSF. Concluded answer natin is combination 3 controls and the required factor load capacity is 69.60 PSF. Okay? So yun na, ang goal lang nito is hanapin yung pinakamataas. Next is floor. Dalawa yung given also for dead load and live load. So, pwede natin din nagamitin to. Ito, yung sa combination 3, dalawa kasi yung unknown, may unknown na kasi dito. And if we compared to the 2, mas mataas tong live load natin. Live load and dead load lang kasi kailangan dun. Ito, wala na rin to. Kasi mas mataas din pa rin to. Okay, 1 and 2 lang. That's combination 2 controls. And the required factor load capacity is 202.40 PSF. So I think, malinaw siya. Substitute and then simple algebra. Next, for each of these systems, determine the required ASD load capacity, which load combination controls. Solution. Sa roof, wala tayong earthquake and wind. Resin natin to. Pwede itong gamitin, pero wala man din tayong live load. Di ba? Pwede yung combination 4, pero wala tayong live load sa roof. So, pwede natin siyang i-cancel kasi mas mataas yung sa D, ay yung sa 3 compared sa 4 if wala tayong live load. Gagamitin lang natin is, actually, pwede lang natin gamitin dito is 1 and 2, 1 and 3 lang. But since nasa pagitan mo siya, so isali ko na lang din, okay? Combination D, 30, substitute lang yan. Combination D tuloy. Combination 1, that is 30, substitute lang yan. Combination 2, 30 din kasi 0 yung live load natin. Combination 3, okay, medyo, kung tayo dito, meron tayong snow kasi na 21. So, i-add lang natin, that is 51 PSF. Okay, ang concluded answer natin is combination 3 controls and the required ASD load capacity is 51 pound per square foot. Next naman is sa floor. Pero sa floor natin, dalawa lang yan. May live load and dead load. Pwede natin itong alisin. So, ito lang, di ba? So, mas mataas man to kaysa dito. Mas mataas man to kaysa dito. 75% lang makunin dito. Ito, 100% siya. Ito, wala tayong live load dito. Ito, same lang sila. 75% lang kunin. So, combination 1 and 2 lang pwede natin gamitin. I mean, may mataas na mabibigay na required strength. Okay, sa floor, combination 1, substitute lang natin dead load. Next, combination 2, substitute lang din natin. And then add. Answer natin 142 PSF. So, answer natin thus, combination 2 controls and the required ASD load capacity is 142 PSF. Okay, number 5, structural steel buildings frequently are designed with diagonal bracing system to resist lateral loads, horizontal force resulting from wind or earthquake loads. Okay, feel ko maganda to sa mga wind na tayo and earthquake. A certain bracing system is subjected to the following load: dead load 13.3 kips, occupancy live load 6.9, roof live load 1.3 kips, snow load 1.3 kips ulit, wind load 150.60 kips, and earthquake load 161.1 kips. Okay, proceed tayo. Determine the required factor load capacity for LRFD, which load combination controls. Observe mo tayo, okay? Combination 6 and 7. Pwede ito siya. Wait lang. Yeah, pwede siya. I mean, hindi siya pwede siya hindi na gamitin. As you see here, same sila, di ba? But here, medyo nag-differ sila, mas mataas yung combination 4. Pwede natin gamitin 1 to 5 lang. Okay? Okay, combination 1, substitute the dead load and then multiply. The answer 18.62 kips. Combination 2, substitute. Yan. To, no, 1.3 lang dito. Yan, same lang sila. Substitute, multiply mo to, multiply mo yan, and then add mo sa lahat. Ganun lang, all process. So, yung pinakamataas. Nabawa, may choices tayo dito. Yeah, live load and wind. Ano yung pinakamataas? Yun yung gamitin natin. Sample na dito. Ano yung pinakamataas? Yun yung gamitin. Since dito is, same lang man, 1.3. Kaya yun ang isang ginamit. Then, simple algebra ulit. Combination 4, meron tayong 17, 0.66 kips. Combination 5, meron tayong 18, 0.77 kips. Okay, ang concluded answer natin is combination 5 controls. The required factored load capacity is 180.77 kips. Yan ang answer natin sa 1. Letter A. Okay, letter B. Determine the required ASD load capacity, which load combination controls. Observe muna ulit tayo. Dito, as you can see, same sila, di ba? Combination 5 and combination 7. But here, 60% lang kunin sa combination 7. Dito is 5%. 100%. Meaning, pwede natin alisin itong combination 7 and 8. Kaya ang gagamit natin 1 to 6B. 6B. Ay, wala pa tayong earthquakes. Okay, tama yan. Combination 1, substitute ulit. Substitute lang man to. Then add, yun, combination 1, 13.3. Sa 2, 20 kips. Sa 3, ikunin natin 1.3. Same naman sila. 14.60 kips na yun siya. So, dito naman, 13 point. Dito, 1.3. Dito, 1.3. Oh, yan o. 1.3. Okay. I think di naman to kailangan i-equal pa. Like, ulit-ulitin. Ganun lang man din. Like, substitute and then simple algebra. Kung ito is kunin yung pinakamataas na required strength. So, dito, so far, meron tayong combination 5 na pinakamataas. Tignan natin dito isa. 6B. Okay. So, I think combination 5 ang nanalo. The combination 5 controls and the required ASD load capacity is 126.07 kips. So that's it. Salamat and God bless.